Welcome to Part 8, in our new game development series, focused on the 3D Flax game engine, and the fourth in our specific Wolfenstein 3D game tutorial. If you remember, in our previous video, we have been able to make our enemy change sprites as we move around it, making it look 3D. We implemented a simple animation system that only was able to change the sprites based on the orientation of the player. In this video, we are going to extend this into an almost full-blown animation system that will allow playing animations independently from where the enemy is looking at. We will also start to blow some intelligence into our enemy to be able to chase the player around the level using the navigation volume from Flax. So, don't lose more in time, and let's jump into the action. The first thing that we have to do is to fix the sprite. You can see that, when we first grabbed the sprites and used them in the tutorial, those white borders were never completely removed by adjusting the size of the sprites. We have cleaned it and resized it to 128 pixels to be better defined. Let's grab the sprite and import it into Flax. Set the Is Atlas checkbox and the size to 1024. Click on the Import button to continue. Let's double-click on the imported sprite sheet to open the window that allows defining the sprites. The sprites are organized in columns and rows. The animations that need to be rotated are organized in columns for the different views, and then in rows for the different frames in the animation. Some of the animations, like fire or death, are not to be rotated and are set in columns. Our animation system will have to consider both. So, we are going to name our sprites based on the pair column row. So the first one will be 01. The dimensions in X and Y are 128, and the first sprite is located in the 00 space. You can see that our first sprite highlights in blue. Let's create the second one, which will be 02, the same sizes, but now it will be located at position 128 in X. Let's do a couple more in fast forward and then we will cut the video and come back with all the sprites defined. Finished, you can see that we have all the sprites in blue, meaning that all of them have been defined as sprites that can be used by our system. Now, we need to replace the old sprite that was being used with the new one. So, drag from the content folder the new sprite into the sprite field in the enemy hierarchy. Immediately, you can see that the border around the sprite disappears, and since we have increased the resolution, the sprite looks much better. Let's see it from all angles by running the game. Looks great. Let's make the changes now to the sprite renderer script to create the animation system need for the game. Double-click on the sprite renderer script to open it. To control the behavior of the animation system, we need to add some variables to the animation structure. So, let's add two Boolean variables. Rotated, that will be used to check if the animation is supposed to be rotated and we move around the sprite. Looping, to check if the animation is to be played once or to be looped. Now, to be able to play the animations by name, let's create a dictionary that will hold a string, the name of the animation, and an index to the animation to be played. In Flax, dictionaries are defined as ordered. Dictionary. We need also to keep track of the angle from where the animations are supposed to be rendered. This will be used as an index through the different columns of sprites. Let's now make the changes in the functions. The first one that has to be done is in the initialization of the animation, as we need to set the animations based on the different angles that the animation can have. So, that means, if we have 8 directions from where the sprite can be seen, each frame of animation will have 8 possible sprites. So, all 8 possibilities need to be saved to be able to be rendered if the angle changes. So, let's create a variable multiply that will hold that number of sprites. Now, let's save in the dictionary the name of the first animation, and the position where it is located in the array of animations. We do it by adding to the dictionary the pair name and index of the animation. Now, depending on if the animations are or not to be rotated, let's initialize it to 7 if the animation can be rotated, or 1, if the animation is not to be rotated. In the next loop that iterates through the sequence of frames that makes up the animation, we are going to need to make some adjustments. So, as said earlier on, each of my frames to be painted on the screen can have 8 possible frames that we don't know which is, as it will depend on the angle from which the enemy is being looked upon. This means that for each frame we need to save the 8 sprites saved in a row in the sprite sheet. let's calculate the index for that. It will be the current frame of animation, that points to a particular row. -1 to adjust for including the 0. Now, we need to take into consideration and save all the sprites in the row. So, let's add a new for loop where we are going to iterate through the sequence of sprites that represents the same frame from different angles, which is held by the variable multiply. Now, the sprite index that we use to point to the atlas of sprites will be calculated taking into account both the frame and the sprites associated with all the angles. So let's set the SPR index to the animation frame multiplied by 8, as we need to jump across all the previous sprites, and then iterate through all the angles for the frame. Let's save then the sprite in the sprites list. As we can see, we are saving each sprite for each frame of animation. We will have to take this into consideration when rendering the frames. Next. So, go to the play function and copy it. Let's the anim type to string, and let's add a new parameter angle, which is the angle from where the sprite is supposed to be seen. In the function, current animation now needs to be set, from the getting the index in the animations dictionary. And the current angle is set from the angle passed as a parameter. Let's comment out the frame to be reset to 0. Now, let's go to the render frame function. First thing to do, is to guarantee that each frame is rendered when it is supposed to be rendered. So, let's create a variable time pass that we will use to control if the time between is bigger than the time between frames. In the render frame, let's add time delta time to time passed. If the time is bigger than 0.08, then we will render the next frame of animation. 0.08 is 1 divided by 30, so we are setting our animation to run at 30 frames per second. If the conditions, let's replace the looping variable with the one that is now defined in the animation. In the if statement, where we render the frame, we need now to get the sprite associated with the frame and the angle of rotation. For this, let's calculate a new index, fr, that will be based on the current frame of animation multiplied by the number of sprites per angle plus the actual angle that we want and that is referenced by current angle. If the animation that we are playing is not rotated, we will go with the actual frame, and if not, we will go with the new index calculated. Let's save, and let's go back to the scene view, and adjust the new sprite renderer. So, for each animation that we have, let's specify what our frames are to be taken into account, and which are the number of rows that we have in the animations. We need also to check if the animation is to be rotated or not. So in the case of idle, we have only one, which is 0. In the case of walk, we have 4. Which are 2, 3, 4, and 5. Of course, when we are initializing the animation, we are actually copying all the sprites between 10 to 56, which are associated with walking from all directions. To see the results, we need first to make the changes to the script enemy soldier. Let's open it. And in the update, where we have the function sprplay, let's replace it with sprplaywalk. Let's run the game. And we can see that everything is running correctly. Our German soldier is walking in front of us from all directions. Let's bring some intelligence into the game now. For that, and to be quick, we will be using the basic tutorial on navigation for Flax. We will be putting the reference in the description to get the code base that we have used. But, first thing, is to create the navigation. So, from the toolbox, under the Other tab, drag the nav mesh bound volume into the level. Adjust it to be more or less where your level is. In the Scene window, from the View menu, click on the option Show and then Show Navigation. You should then see in a green color the walkable region for the enemy. To be able to use it, we need now to copy the code from the tutorial into our enemy soldier and make the correct adjustments to have it work correctly with our enemy. We need to make some changes. First thing is to make move to target private, as we have already a reference to the player. Let's initialize the speed with 200. Then, in the on start, let's set move to target to be player. Let's copy the second part of the code, which actually what will make our enemy move through the level. Paste it in the on update after the code that we have for the orientation of the sprite. Let's do some changes. Let's go up to the start of on update, and let's create a new variable called sprite deer. Let's replace each of the sprite play walk that we have set earlier on to be sprite deer and take the value of each of the directions. In the new code that we have pasted, where we are checking if the enemy has reached the target position. If we have reached the distance to stop, we will start to play the animation to idle, and if not, we will place the walk animation. In both cases, as a direction, we will use the sprite direction referred to in sprite deer. Although distance squared is better from a point of CPU efficiency, let's use the more traditional distance, and instead of using a hard-coded distance, let's make it into a variable distance to stop that we will set to 200. Remember that in Flax everything is in centimeters, so we are saying 2 meters. Now, time to take care of the movement. If you remember, we are moving in the onFixed update, through a vector called velocity. So, if we want to move or to stop, we need to set velocity to the right vector. In the new code, where we are setting the actor position with the difference between points in the navigation path, let's comment it out. Let's set velocity to be the normalized difference between each segment of the path. This will give us a vector of movement along the discovered path. Let's go to Flax and see if it compiles. No. We have an error. We have not initialized the sprite dir variable. Let's do it quickly. Let's run the game. And we can see how the enemy is going after us. Let's run away. We have a small problem. Sometimes he is walking after us but looking in the wrong direction. There must be something wrong with the orientation function. Let's review it. We need to adjust the angle to be considered as looking forward. 10 is too skewed. We are going to increase it to 30. Let's also mod the rotation by 360, as to have always values that are between 0 and 360. Finally, in the code where we are testing if in distance to stop or not, let's replace the sprite dir by 0 in the case that the enemy is not near the player and chasing it. This way, while chasing us, it always looking in our direction. Later on, when implementing some machine states, we will be able to choose whatever or not to take into account the rotation. Let's run the game again. And finally, the enemy is chasing us correctly looking at us, if it gets in range, it stops, and when off the distance he starts to chase us again. And of course, always looking at us. We can go around the wall, and he will follow us as we are using pathfinding. Let's close for this video. In the next video, we will implement a simple machine state to patrol and chase, with an attack, hurt, and death states and their respective animations. Thanks for watching up to the end of this video, and we hope that you have liked it. If it has been the case, then don't forget to like the video, it is a good way to support our work and to make more people find us. Don't forget to subscribe and to click on the notification button, to be alerted for new weekly videos. If you have any request on where you want the tutorial to go, any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.